enjoying this presentation. So the idea is to introduce you some projects that are being developed using ontology in to show the potential and what's the utility of doing that such a huge effort in developing and producing this kind of artifacts. So our agenda is like this. I would like to introduce myself and my group, discuss why ontology is important for petroleum industry and in some senses similar problems in very different types of big industry, and then show you our catalog of petroleum projects, mainly those that are being developed nowadays in the group. Then I will let you some contacts and reference about the work that we are doing. So I myself, I am a geologist. That's why I am working for petroleum exploration for a long time. Information, but I have done master in doctor degree in artificial intelligence and computer science. So nowadays I am a retired professor at the Federal University of Rio Grande do Sul and being active as an invited professor in the Informatics Institute of Federal University of Rio Grande do Sul. So I start with classes in the involvement of undergraduate courses and is mainly focused in the collaboration and research in the university. So only active nowadays in the post-graduation program. So I am the creator in the Informatics Institute of the E-Fuels Energy group, which is the group that develop a lot of projects of informatics applying for petroleum industry. I myself have a large experience in coordinating projects of collaboration, international projects, but especially in the exploration part of petroleum industry. Nowadays, I am more in production part, but it's a kind of change in the common path of my research. So here we have our contacts. So why does the petroleum industry go further looking for ontology solutions? The main problem is that it's a very advanced industry that is all the time take the boundaries of the state of art in any area, technical area of research. But nowadays they are in a transition from empirical way of dealing with database support that manage of data to go to a digitization model. I mean, they are coming into the industry 4.0, 4.0, and this requires the adoption of standards. And then there is plenty of standards in petroleum industry, but these standards is more a regulation of the terminologies, more like thesaurus. But they need now the step of transforming these standards in real artifacts that can be used by machines. So the challenge is to produce transform the actual standards in terminology that can be understood by person, but can be processed by software. So that's the nowadays problem related to so big demand on ontology for this industry. Also, they have a lot of knowledge-intensive problems that's common for a very advanced scientific industry. So the problem about having this knowledge-intensive is that you need to model the knowledge inside of the application. Then I will show one of our projects show this, both the digitization problem and the knowledge-intensive needs for processing data and application. So all other problem is very, very common. So the producing petroleum is very complex. So it's not a case of one company to do everything along of the exploration and production. They do this with collaboration with thousands of companies. And each company has their own data format. They store information in they have the proper vocabulary and so on. And sometimes when this company produce very good software, they build like a kind of silos that keep the data stolen, trapped in these formats. So it required some standards to exchange information, and these standards are also supported by ontology. And also, since they are very complex, they have plenty of technical areas, I mean, engineering, geology, geochemistry, with very a large set of people working that have communication problem with each other. So ontology helps in doing this too. We deal with all these problems in our projects. So basic is like this. You have the activities, you have the geology, you have the seismic guy, seismic interpreter, you have the production engineering. Each one of them has a set of software that support the activity, and this software has data models that implements the view of this professional or this technical area. So for each set of software, you have this common view related to geology, related to seismic, related to engineering. But the problem is that when you need to produce results, we need to integrate, we need to migrate the data from one software to the other. So we have this problem when we put them all working together. And the answer of this problem is ontology, how to map the terminology using in one database, in one application to the other. So the idea is to use ontology to integrate this. So the ontology is the saint grail for solving the problem of interoperability among these several applications. But you know that is not like this, not really. Ontology cannot solve all the problem of communication, but ontology helps a lot in several types of problems in interoperability. So we can help in indexing and search over the information through different domains. We can provide support for data integration under the same view. We provide indeed system interoperability. We try to build bridges between the island of information. And one thing that is very important nowadays, if you want to process the data in large volume, we cannot wait that this processing is done by people, by person. It requires large applications that can deal with big amount of data. And to do this, we need to bring this data to a common standard, common view, common vocabulary. So what we are doing a lot is to doing training on supervised in machine learning with support of ontology. We provide to the training algorithm, we provide the classes and the meaning, what we intend to put in each classes. And these classes is defined by ontology. And then we have plenty of knowledge-based system. One thing that we do as a general approach is try to find in the domain in many of these different applications. We try to find the rigid entities that are providing identity, and using this entity to provide like a framework of reference between different models and different ontologies in this domain. Then what we do is try to look and to find this entity and use this entity to keep track of the evolution of the data and interpretation between applications. Has a general approach. So I will talk about a little about our industrial projects. We have several others that I will not mention here because of the time that we have available, but I will try to show, at least in the two ongoing projects, what is being applied and what's the research, in order to be not so abstract in general. So we have plenty of previous projects using ontology. Several of them are commercial software today that's being used in several countries. Some of them that was developed, supported by Petrobras, it was adopted by Petrobras and used in daily basis, then is not sell for other companies, so we have everything. As an example, we have the petroleum, that was my PhD thesis, that support systematic description using a formal vocabulary for petrographic analysis of reservoir. Then we got this vocabulary and we developed the rock viewer, which is an image annotation and retrieval system for image for petrography. Then we changed the scale of analysis for macro scale, and we developed an ontology for sedimentary phases, now adopting a top ontology because petroleum was done in 2000, and we don't have this approach of using a top ontology. But when we developed the strata ledge, then we adopt UFO has a top ontology for this ontology for sedimentary phases. Then we go further and we move to develop a core for integration of information in geology, and this GeoCore ontology was based on BFO ontology. It was derived from BFO, and then GeoCore supports the GeoDigital project, what is information indexing and information retrieval in the Petrobras environment. In this project, we recover and structure information based on ontology, but also we develop a full branch of the project to model the types of images that are using in petroleum industry for reports, for study, for analysis. So we have a typology of images, and we use this typology for annotation and recover in the databases and in document bases of Petrobras. So all this project was already finished and is being used by industry. Now we have some small projects that I will not mention here, but we are now developing two projects, with one PetTwin with support of Libra, is a consortium of petroleum industry, and GeoReservoir is supported by Petrobras. PetTwin is in the industry, is the production of petroleum, and GeoReservoir is exploration, I mean, is a geology studies project. The energy group here has other petroleum projects in bioinformatics, high-performance computer information retrieval. We have several cooperations with Petrobras in the Informatics Institute, but I will show you only the project which the main focus is ontology and semantic. Let me check the time here to not go too long in this presentation.
It's okay.
Okay, not too bad. Okay, so PetTwin project, what we are doing is to do the semantic integration for digital twin. What is digital twin? I have the physical installation, I mean a petroleum plant like this in the picture, and then I have a set of service that running over this physical installation, like real-time monitoring and data analytics, because the plant production need to be monitoring real-time all the time. It's not real-time, but is no interruption. Is right on time, the technical work. To do this, we need some virtual representation of this plant. And we intend to do virtual representation of the whole plant, the whole data, the whole sensor, the whole installation, and so on. So this is being done by industry, but the problem in doing this virtual representation is that we need a uniform terminology that is mentioned for each one of the process that is running in the plant. So informatics of URGS was contracted to develop an ontology that supports this integration among the several projects that is running in a platform, which is a very, very complex thing. So the requirement of PET2IN was terminology harmonization through this whole plant. We have this first phase of the project is one part of the process, but we are expanding for the other in the next stage. The idea is to get not only the terminology harmonization, but also easy access to definition of facilities, of equipment, and the technical specification of them to help engineers to find quickly and to check if this equipment is okay, needs to be repaired, support a lot of tasks on this. And then support knowledge-based application, data analytic, and so on. So it's the main requirement is this, an ontology for uniform terminology and put together technical specification of the facility. So we need to deal with the Babel problem. Here we are modeling in this first phase the physical entity of a petroleum plant. You take this picture, and each equipment, each piece of sensor, everything needs to be modeled. So we are, that's why we adopt BFO, because BFO is based on material entity. Then we define all the properties that characterize them, and then all the relationships between this entity, mainly based in the composition, flowing connection, and location, because relationship here is connected, is related, like this pump has a pipe that's connected with the well, and so on. So we have all these relationships defined. To do this, what we have done, we have interviewed technical people in 6 areas of Petrobras. Then we choose one area which is called flow assurance, which is the area that monitoring the well and assure that the petroleum is going out of the well. That's the name. That's why the name is flow assurance. So we choose this area and start to focus on this. So we interview like 25 people and 100 hours of interview. So after that, we got the competence question for this area of flow assurance. We keep the others frozen for now. Then we choose the term from the interview, we choose the term to be included. We do a lot of research over technical documentation, over standards in the industry, and so on, to take the definition and the terms that should be included in this ontology. Then from this material, we get the definition, we merge the definition from different standards because they are not so uniform like we are expecting. Then we do the conceptualization, I mean the Aristotelic definition, and then we do the implementation in O, and we develop also a software for use case application. For you to understand, our team for this project is 32 people, so we have a lot of main power to develop this project. So the focus is to model the entities, I mean the continuants, but also model the process. The flow assurance is a process. I need to guarantee that the petroleum flows out, and then I have maintenance, a lot of process involved in this. From now, what we have ready is the continuant part, but we are working this last month on the current. You know the doctoral thesis of Fabrício Rodrigues is mainly focused to solve this problem, but we have other ontology also work on this. So the result is the OTPO, an ontology for the plant facility. We have the independent continuant for each one of the entities. We define the properties and you define the connection between the equipment and the type of connection, and then we detail all the properties that are used by the process and software that run this this petroleum plant. This is only, again, only for flow assurance. I mean, is well and bombs and pipes and this kind of thing. If we are going up for the topside installation, and you are going down for the reservoir activities that control the behavior of the reservoir. But this is the first phase of the project. So the application scenario is this: we have the well, we have the pipes that take the oil to the surface. It is offshore, so is in the ocean, the application. Then we have this tag that have all the measure of the well, and we translate the tags for a formal vocabulary. So we take all the definition of the well, of the tags, of measure, and we have a translation for each part of this measure to a formal vocabulary. Sorry, it's in Portuguese here, but we have this double language in the ontology. So the architecture, we implement a system for vigilant of production. Is vigilant of production ontology. So it's an application based on ontology. Just a general view of the architecture. The triples are stored in MongoDB. We have the Sulescence that has the front end to examine the ontologies, not to finish totally this part. And then we have an ontology mapper that support the application that need to consult the vocabulary and then connect with other application in Petrobras. So you have a general view of the application. You can select the wells, and then you can examine the wells. You have ontology hierarchy and properties and components and relation. So here you can select, and here you can view the data on the time to see the behavior of the data evolution of the data. Then you have the data analytic for temporal series that follow the behavior of the data through time. Then we have several machine learning analytics. Here we have the forecasting that try to preview the behavior of production using the past data production. All this is uniformized using the ontology. Okay, then the second project, I will go quickly on this. And the second project is coordinated by Joel Carbonera. The idea is to have this very geology empirical description of the sites, geological sites, translated to a parameterized description that can support data analytic and machine learning. So the general idea is to bring a very empirical and personal geology to a quantitative science. It's a large effort that the community is doing in this direction. So we start by developing the gel core to support the description, and then we have specified in a particular ontology with gel reservoir. This is the paper that describes these big ontologies, and then we have the spatial relation ontology that describes sites and spatial relation of these geological bodies. And then after this, we have this network of ontology also based on BFO. So we have the GeoCore ontology. We have information artifact ontology that support the ontology for description. And in GeoCore, we derive the GeoFault, which is the PhD of Yuan Wei Q from Oslo University. We have the gel reservoir, which was developed by Fernando Ciconeto here in Brazil. You have the geospatial relation ontology that support this description. And then you have the software we call Saga application with all the vocabulary, again in Portuguese, because people in Petrobras use important. So all the vocabulary of description associate to seismic section. So which object that we can find in the section is described use this controlled vocabulary. And then we do statistic over this. distribution of the bodies, how is the region of dimension, of height and size, and so on. Everything controlled by the vocabulary. This is a running software. We install a first version in SAPes Petrobras in November now. Then the back end is like this. We have the ontology here. Storage is in triple stores, and then we have Jena to run the applications. And then we have this interface of front end. So our network ontology today based on BFO, so it supports tags of petroleum production monitoring, the production plant, so the authors are here. We have the gel core for petroleum geology, the deep marine deposit ontology, and we have the picture images for exploration using the EIO ontology has a support, and we keep developing new ontologies connected, integrated with this. So the main demand is done by the 4O industry, which requires that all the information will be uniform and parameterized. So it's a large effort from the industry doing this, and ontology is a big effort. So you know that's a big effort to get an artifact that's operated, that can support a software, but is rewarded by the effective reusability. We're using several applications. I just show you the main application using this ontology, but for documentation, for a lot of things, ontology is useful. So this is my ontology group in the energy area. So Professor Joel Carbonera, Cauã Antunes is a PhD, Nicolau Santos is the producer of O3PO, Fabrício Rodrigues, which works with occurrent events and occurrence. Luan Garcia is the author of GeoCore, Alcides Lopes, which is working with machine learning to extract from text and do automatic classification in a top ontology terminology. So Rafael Petri is a beginner, is starting now the master, and then I have the master students here in the corner, which is they will work for the next 2 years in these applications. And my contacts. That's it. Thank you for your attention.